All right, go ahead and have a seat. So today we are starting inequalities. You guys will know them once you see them. You might remember them already. We're going to be talking about graphing and solving and writing. Kind of doing a little bit of everything today. We are starting out with a video, very short video.
When the stakes are high. At work, your tone matters. Grammarly's advanced tone suggestions can help.
Hello, ladies and gentlemen. Today we are going to be talking about 6th grade standard equations and expressions, number 8. This says that we'll be able to write inequalities that represent real-world situations in the form of x is less than some quantity, or x is greater than, should have done that, greater than some quantity, right? And c is just standing in for some quantity. So let's see what this might look like, right? So imagine a situation or a problem where you say, last night the temperature fell below -2 degrees Fahrenheit, okay? And they want you to represent this statement as a mathematical statement, a mathematical expression, an inequality. Now, we call it an inequality because we don't know what the temperature equal. We only know what it didn't equal. So that's where we get the word inequal. It is not equal. So let's take a look at how this might be. We could say the T, now that's the number that stands for the temperature, right? It's a variable. We do not know what the temperature was. All we know is that the temperature was less than -2, right? So this is not an equality. We're not saying the temperature is -2. We're just saying it's some number less than -2. We can imagine some numbers might be -3, could be -4, it could have been -50, my lord. So it could be anything. And so when we don't know what something equals, we use an inequality. This is called a constraint. We just know that it is less than 2 degrees. Okay? It's not 4, it's not 5, it's not 100, it's less than -2. All right, so let's take a look at some other examples here. This says less than $260 was spent by the Garcia family. So already we're seeing where the inequality might come in here. It's less. We're spending less money than $260 was spent by the Garcia family on groceries last month. Write an inequality to represent the amount the Garcia family spent on groceries last month. All right, well, we don't know how much they spent, so let's just use S for the unknown amount of money that they spent. The constraint is that it is less than $260. And we're done. That's it. Our inequality shows us that this number will be less than 260. So these inequality symbols, let's take a quick moment to remember how they work. This is the small portion of the inequality sign. It's pointing to the smaller number, right? They spent less than. And this part right here on the right, that is much bigger. It takes up all that space. That is the greater number, right? This is the greater number. 260. Okay, so that's it. We're also asked to graph this on a number line. So this number line is blank. That leaves us, it's a bit of a mystery, right? Where are we on this number line? Well, we can be anywhere we want to be. So let's start off by giving ourselves, start where we know. The number we know is 260. And when you graph, when you have to create a number line, make sure you show that you know which direction it goes in. I know that as I move to the right, the numbers will get bigger. And I'm going to make sure that I'm showing intervals. Notice this space right here. I tried to make it exactly the same as this space here. This space showed a jump of 10. We'll try and make this show another jump of 10, so this would be 280, right? Number lines always have to have equal spaces in between them. And in this case, our space is equal 10. So the 10 less, right, we're moving to the left now, less than 260 is 250. Another one would be 240. All right, so we've established where we are in the number line. How do we graph an inequality? Well, I'm going to start by making a big circle. Let me switch colors here. I'm gonna start by making a circle, an open circle above 260 to show that 260 is not one of our possible answers, right? They did not spend $260. They spent less than 260. Some of the numbers that are less than 260 are 250, 240. Heck, it could have been 200. It could have been 1. I hope not. I hope they spent more than that. But all these numbers are possible solutions for the letter S, for how much they spent. So we want to create an arrow that covers all those possible solutions. Now, I can't make an arrow that's long enough to cover all those numbers, so I'll put an arrow at the end of it here to show that it continues down the number line to the left, all those lesser numbers. All right, let's take a look at another problem here. Jonas spent more than $40. So now we're talking more than $40, and he spent more than 40. He could have spent $1 million, right? So I'm going to say he spent more than, right? Notice that I have a larger part of the inequality now, the larger part of the inequality sign pointing that way, pointing toward the larger number, and I'll put 40 over here. He spent more than 40. And notice the smaller part of the inequality sign, the teeny part, is pointing to the smaller number, the lesser number. Okay, so there we go. And just read it back to yourself. He spent more than 40. That's right. He could have spent 50. He could have spent 60. He could have spent $10,000 at the amusement park. I hope he did. That sounds like a blast. So on the number line, again, I'm going to just put my number where I'm starting in the middle. I'm going to orientate myself, say these numbers are larger. These numbers to the left are smaller. I'm going to create an open circle above the 40 to show that he did not spend $40, but he could have spent 41. Heck, he could have spent $40.05, right? So that's why we need to get really close to the 40, not include it. That's why we have an open circle. And we want to color in 41, 42, 43, all the numbers above 40. And that's it, ladies and gentlemen. You have written an inequality in the form of a variable is greater than a quantity, and you've graphed it on a number line. Excellent.
All right, so essentially it's kind of what we're doing, and like I said, we're adding an extra step of solving a few of them as well. You are going to need a red and a blue out today, so please get that out. Do not talk at all. There's no need to talk. All right. So before we get started, we do need to discuss a few things. All right, so please draw those symbols across the top of your page. All right, so the first one. What is that symbol?
I mean, yeah, no, less than, sorry.
Greater than or less than?
Less than.
Very sure. So this one right here, we're saying is less than.
Oh, I'm sorry. Greater than.
Are you sure?
Yes.
You seem very confused right now.
Greater than.
Positive.
Positive.
Alright, so greater than. Alright, one underneath it. What's does that stand for? Christian,
Less than.
less than. Alright, top one over here with the line underneath it. Cooper,
Equal to or greater than.
greater than or equal to?
Oh yeah. Does it count the other way? No.
Gotta say whatever it is first and then equal to, or equal to. Alright, and then obviously the last one is what? Last one is what? Jack?
Less than or equal to.
Can I have your attention, please? If there are any 8th grade boys interested in playing football at Havelock High School, please report to the auditorium at this time for 10 minutes. Any 8th grade boy that's interested in football for Havelock High School, please report to the auditorium.
Alright, so we are starting with these top 5 boxes, whatever you want to call it. And we're just simply going to write an inequality that represents each one of these. So this says a number minus 5 is at least 16. So a number minus 5 would look like n minus 5. And then we have 16 over here. What goes in between? Greater than, less than, greater than or equal to, less than or equal to. What you're going to do is you are going to stand up when you think you know the answer. So stand up if you picked greater than. Stand up if you picked less than. Stand up if you picked greater than or equal to. Stand up if you pick less than or equal to. Ethan, get it together, child. Alright, so we're all agreeing that it is greater than or equal to. Why? Why did we pick this one? Jackson.
Because if it has to be at least 16, either it's going to be exactly 16 or greater than 16.
Okay, so keywords that are at least 16. Alright, the next one. A number increased by 10 is less than 30. So n plus 10 is increased by is less than 30. Alright, so again, we'll do the same thing. Stand up if you think this is greater than. Stand up if you think this is less than. Thank you, Lord. Yes, it is less than. So it's right there in the little situation. Alright, 4 times a number is no more than 40 3/4. So we have 4n and 40 3/4. Alright, so stand up if you think that this is greater than. Stand up if you think this is less than. Stand up if you think this is greater than or equal to. Stand up if you think this is less than or equal to. Why is this less than or equal to? I'm like, no more than.
So it could be equal or less.
Okay? And then the last one, the quotient of a number in 6 is more than 2 3/10. So n divided by 6, and then 2 3/10. Alright. Last time, stand up if you think this is greater than. Okay, so everybody's standing, yes, that is correct. Alright, so the next one. Max's vet said his puppy will grow to be at most 33 inches tall. The puppy is currently 1 foot tall. Write an inequality to show how many more inches Max's puppy will grow. Alright, so if we go back through this sentence, Max's vet said his puppy will grow to be at most 33 inches tall. What's important in that question? Cooper.
The utmost part,
The at most. Why is that important? Cooper.
because that can resemble like it's less than greater than or equal to or less
So which one is it?
less than
What is it?
less than
Less than or equal to? So you're saying it's that one? Okay. Anything else in that sentence important?
equal 33 inches tall.
Right. Alright, the puppy is currently 1 foot tall. What's the point in that sentence? Emily?
He's currently 1 foot tall.
So he's currently 1 foot tall. Alright, in inches, what is that?
12.
Alright.
12 inches.
And then the last sentence says, write an inequality to show how many more inches Max's puppy will grow. Alright, what is this gonna look like? What is this gonna look like? So, we wrote the scenarios up here straightforward. This is a word problem that you have to write the inequality for. So what do we think it's gonna look like? We already know that it's less than or equal to. Michaela?
12 is less than or equal to 13, or 33.
Because you have to show how many more inches.
Oh.
Caleb?
12 times
12 what?
times
Nope.
12 inches plus n is less than or equal to 33 inches.
Okay. Okay. Alright. Graphic. So they talked about the open and excuse me, the open and closed circles in the video. Alright, so less than or greater than, you have an open circle. Okay? Less than, equal to, greater than, equal to, you have a closed circle. This means it is included in your solution set. Your solution set is the set of numbers that will make your statement true. When you're doing inequalities, the thing you want to think about is, does this make the statement true? So if you're saying that n is less than 4, but then you say 5 is less than 4, does that make that statement true? No, because 5 is not less than 4, 5 is greater than 4. So that's how you know if you're going to be able to include the number or not include the number. So we're going to go through and we're going to graph these. So someone read me what this inequality says right here. Ace?
X is greater than negative 8.5.
Okay, so we're going to find negative 8.5, which is over here. Ace, is it an open circle or a closed circle?
It will be an open circle.
Okay, and few ways that you know that is, one, would you say negative 8.5 is greater than negative 8.5? Is that true? No, it's equal to. So therefore, you know you cannot include 8.5. There is a trick though. If your variable is on the left side, your inequality points the direction of your arrow. So with it being x is greater than negative 8.5, it's telling us our arrow is going that way. Okay? However, if it's on the right side, it's the opposite. So if it's pointing to the left, you're actually going to the right. Okay? Just something to think about. All right. So, excuse me. Someone read me the next one. The next one. Ethan,
X is less than 2 3/4.
okay? So 2 3/4 is gonna be real close to 3. Ethan, is it open or closed?
It's open.
And which direction are we going?
To the left.
So Ethan, give me a number to the left that makes that statement true.
0.
0 what?
Hmm?
0 what?
Oh, 0 is less than 2 3/4.
0 is less than 2 3/4. Alright, the next one is. I'm raising it, tell me what it is. Jeremiah?
X is less than 7.
Not just less than, but there's a little line underneath it.
X is less than or equal to 7.
Okay? So Jeremiah, I'm gonna find 7. Can I include 7 in that statement?
Yes.
Because if I say 7 is less than or equal to 7, that makes it true. Alright, so you are going to close your circle. And then Jeremiah, am I going to the left or to the right?
You're going
You said that with a question mark. So pick a number to the left and plug it in and see if it makes the statement true. So plug in 3 to the statement that you're graphing right now and see if it makes the statement true. So is 3 less than or equal to 7? So does it make the statement true? So then that, you know that that is the direction of your arrow. Did you guys see how that worked? So like he was kind of unsure. So if you're saying that it's gonna go to the left or it's gonna go to the right, pick any number in that direction and plug it into the inequality and see if it makes the statement true. If it makes a true statement, then you know you're right. If it doesn't, you're like, nope. Because we wouldn't say that 8 is less than or equal to 7. We would say that anything 7 and below is less than or equal to it. Oh, we are totally supposed to be using our colors right now. It's okay. We'll use it on the next side. Alright, -4. Oh, sorry. Someone read me the inequality. Caleb.
-4 is less than or equal to x.
Okay, so we're gonna locate -4 over here. Alright, it's gonna be open or closed?
It will be closed
How do you know?
because you can include the negatives already.
Okay, so it's closed. Alright, now, which direction is it going?
It will be going
The left? Okay, so pick a number to the left and plug it in and say it out loud and tell us if it makes the same or true.
Wait, no, it'll go to the right because it's a negative.
Right, so it's going to the right. So any number to the right will make that statement true. Alright, the last one, have to do a little bit of math to figure this one out. So 13 minus 7 is, oh, sorry, Joseph.
13 minus 7 is 6. Oh. 13 minus 7 is greater than x.
Okay, and so you said that 6 is greater than x. Alright, so Joseph, am I going to include 6 or no?
You don't.
No, because it doesn't make the statement true,
Yeah.
right?
Yeah.
Alright, which direction am I drawing my arrow?
You're going left.
Going left?
Yeah.
So I would say that 6, pick a number and make the statement true.
Negative 87.
Okay, so plug it in and Tell me if it's true.
6 is greater than negative
6 is what?
87. 6 is greater than negative 87.
Yep.
That is true.
Alright, so that is graphing. Questions about that one? What?
Oh, so when they're open, they're just the opposite.
No.
No, when they're open,
When they're open, they're not, you don't include the number that's in your problem. When they're closed, you can include the number. Alright, slide over to this one. Alright, now it is asking you to write an inequality for each graph. So looking at the first one, someone raise your hand and tell me if it's gonna be greater than, less than, greater than, equal to, less than, equal to, based off of the circle. Christian,
it'll be less than or equal to.
it's gonna be less than or equal to, why?
Because it's one is a close circle, and the second one is it goes to the left. The number of grades.
So are we gonna say that x is, you said less than or equal to?
Less than, yes.
Less than or equal to 6? Okay, Christian, pick a number that is less than 6 and plug it in to make sure that it is true.
X is greater
Pick a number less than 6, plug it in, and make the statement true.
Figure 4 is less than or equal to 6.
Okay. Alright, next one. Tell me if it's gonna be greater than, less than, greater than, equal to, less than, or equal to. Caleb,
It would be less than.
less than?
Wait. No. Wait. So that would be to the right. That would be
So are you putting x to the left or to the right?
X is to the left. So,
Okay.
X is greater than negative.
Alright, and the last one. Alright, Hunter.
X is less than or equal to 1.
Okay.
And let's say, yeah, 3. No, sorry, not 3. I'll take it as 6. Negative 4. Negative 4 is less than or equal to 1. I don't know why it's negative.
Alright. This last section down here is the solving part. And for whatever reason, we absolutely lose our minds and are like, we don't know what to do. Your inequality is just like an equation, except for in an equation you have an equal sign, right? Here you have an inequality. Everything else is exactly the same. You're still doing the inverse operation. You're still trying to get the variable by itself. So for this first one, if x is over here, I'm going to add 9 to this side, cancel it out, add 9 to that side. X is less than 5, and that's what I graphed. It's not difficult. It's just like solving an equation, except for the equal sign is an inequality. Alright, and then to graph this one, we would go to 5. Would we have an open or a closed circle? Open circle, and would it be going to the left or to the right? The left. Alright, the next one. Negative 3/4 plus x is greater than or equal to 2 and 1/4. Alright, so how do I get my x by itself? What do I have to do to the 3/4? Caleb?
Add 3/4 to it.
So that cancels, so I'm gonna do plus 3/4 over here. So x is greater than or equal to what?
Just 3.
Alright. So I find 3. Raise your hand and tell me, is it gonna be open or closed? Open or closed? Ethan, closed. And which direction is it going in? To the right? Your right or my right? Are you sure?
Wait. So
Wouldn't that be the same right?
Yeah, there's the same correct.
Yeah. Both
If-
right.
On the paper, it would go this side.
This side, well, what's this side?
Well, it's the same on her paper.
Yeah, it's the same on her paper.
So like, if you look at the screen,
It's a trick question.
if you look on the screen and you see the 3, it would go to the right of the 3.
So it would go
that
towards
was
the
such a
4.
good explanation. Now I know exactly what's going on.
Or you could just look at with the inequality, like look at what the arrow is pointing, like what the thingy is pointing to, and just go that way. That's what I do.
I'll just say go the opposite way of the first one.
So like for this one, because like for 1, 2, and 3, technically the inequality tells you the direction of your arrow. For number 4, it's the opposite. For number 5, it's the direction of the inequality, and for number 6, it's the direction of the inequality. Whenever the variable is located on the left side of your inequality, that rule applies. If it's located on the right side, it's the opposite. So it's like, so if x is here, you can use the arrow or the point, arrow / point. If the x is here, have to do the opposite. So depending on the location of your variable determines if you can apply that rule. Would you please focus?
Oh, I thought you were talking to me.
We were going to, but I kind of forgot, so there'll be plenty of opportunity for us to use colors. I apologize. Alright, the next one, 15x is less than or equal to -90. How do we solve for x on this one? Christian? Nope, can't take away 15. That's not the operation that's going on there. What operation's going on between x and 15? So what's the opposite of multiplication? So we have to divide here. So you divide by 15, divide by 15. X is less than or equal to -6. Alright, so we find -6. Raise your hand and tell me, is it open or closed? And how do you know? Jack?
Close since there's a line under the less than,
Because it's equal to.
or because it's equal to.
Okay, and then, Jack, which direction is it going? Right or left?
To the left.
Alright, the next one, -8 is greater than or equal to -5 plus x. What do we do here? What do we do here?
Add.
What do we add, 5 or 8?
5?
Huh?
5?
Yep. That cancels, so we do plus 5 here. So we end up with -3 is greater than or equal to x. Now this is where the opposite comes in. So we're gonna go to -3. Raise your hand and tell me, is it open or closed? Open or closed? Haley? It's gonna be closed because we have that equal to. Now, if I use the arrow, and I said my arrow's gonna go to the right, and I plugged in 3, negative 3 is greater than or equal to 3. Is that true? Is negative 3 greater than or equal to 3?
No.
No, that is not true. So that is how I know that I cannot use, or I'm not going in the right direction. This is where you have to remember that it is the opposite. So when I say negative 3 is greater than or equal to negative 10. Yes, that is true. All right, you guys are doing the next two on your own. Stand up when you're done. Okay, so you're doing 6 divided by, or x divided by 6 is less than negative 1, and negative 7 and 2/10 plus x is less than or equal to negative 8 and 7/10. Guys, if I'm doing something on the board, you should be doing something on your paper. Why are you not showing your board? Why? Because you actually showed your work, that's why. Stand up when you're finished. Watch the iPad. Stand up when you're done, guys. About 30 more seconds. divided by 6 is less than negative. Thank you, Alexa, for volunteering. So how do we get x by itself? Huh? Okay, and why are you multiplying by 6? Did you say it's the inverse operation? Yes, ma'am. Alright, so then you have x is less than when you multiply a negative and a positive, you get what? Negative? Negative? Okay, so you end up with negative 6. Alright. Alexa, where am I putting my circle? Is it open or closed? And why do you know it's open? Okay, and then which direction is it going, to the right or to the left? To the right, so is negative 5 less than negative 6? Zero is here, negative 5 is here, negative 6 is there. Is negative 5 less than negative 6? Is it closer to 0? So that it is not less than. It is greater than. So you're going to the left. Alright, the next one. Negative 7 2/10 plus x is less than or equal to negative 8 7/10. River, thank you for volunteering. What do we do first? How do I get x by itself? Am I going to do something with the negative 7 2/10, or am I going to do something with the negative 8 7/10? Say that, I just didn't hear babe.
Negative 8 and 7.
Which one is on the side with the variable?
The negative 7.2.
Okay, so we're going to do something with that one, because we want to get x by itself. So what's the opposite of negative?
Positive.
Okay, so we're going to add 7 and 2/10, that cancels, so I'm going to do plus 7 and 2/10 here. So x is less than or equal to so what is 8.7 minus 7.2?
1.
Because it's 1.5, right? But your bigger number is negative, so then your answer is going to be negative. All right, so River, there's my circle. It's going to be open or closed.
It's gonna be closed.
And which direction is it going? To the left or to the right?
To the right.
To the right?
No, to the left.
To the left? Which way is the inequality pointing?
It would be going left.
It's what?
Pointing to the right.
So it's pointing this way. So the point is going to my left, right? So then that's telling me, because my variable is on that side, that I can go to the left. Alright, so this box right here is part of your homework tonight. Says create a word problem, inequality, then set up, solve, and graph the solution. So everything that we've done, you're applying to your homework tonight. Okay? Glue this into your notebook. Slide over and on the next right page, please go ahead and, title it. What does it say? Now, I didn't say that you could have used something very similar to what's already on your paper. Can't be exactly, but it can be similar. Actually, I think this way. Do I look entertained right now? Alright, so it's Monday. Yes, you have homework. There's no reason you shouldn't get it done. Your homework is this. You are not solving. You are simply trying to write the inequality correctly. You just need to write your inequalities down here in these boxes. Use your colors that we didn't use today, so sorry. And just color your path in whichever direction you're going. So, for example, if it's x is no more than 5, you're gonna pick either down, to the right, or to the left. Sorry, down, to the right, or up. I don't even know my directions. And whichever direction you go, you then use that one and go to it. This is part of your homework, and the one problem from the note page is part of your homework. Okay, when you are finished, please get on Imagine-Math. The amount of Imagine-Math that is not getting done is mind-blowing. You've got to get it done. Okay? If you have questions or whatever, please come and ask. Get started.
No.
Yes, sir.
If we're done with our Imagine Math, can we do the homework that we're supposed to do? Like, not this, but the other one?
The one from the notes? Yeah, I just said that. I would do all my homework first, and then I would,
I'm already done with Imagine Math.
well, you're doing Lexia then. I mean, you're either doing Imagine-Math or Lexia, that's your only options. I'm glad that you're done though. I'm not caring at all. Yes, baby, that is what a word problem is.